This little video here is showing my attempt to make a dust collection, and I'm inspired of my old planner, as you can see here. When I look at the internet, I can see a lot of people are trying to use their shop vac, and they are just holding it tight to the bit when it's cutting, and it actually seems to work very well. So my first attempt here is just to kind of hook up my own shop vac here directly on the CNC, and then do some tests, see how much chip and dust it actually collect and move from the cutting. Of course, there's a limitation here, and the limitation is that the board needs to be same height all. Otherwise it will just hit it or bump into it, and I don't think that's optimal. But for the test here, I think it's okay to do like this. And I'm not running fast, I'm not running deep. I want to produce some dust here and not chips. It's mainly the dust I'm concerned about, so I want to see how effective the shop vac is to clean up the dust. And as you can see here, it's very hard to see there is any dust at all. But since it's a little hard to see the dust it produces, I think I will try something else that is a little more creative than just trying to produce dust. And that is to try to make some fire. And yes, this is crazy, but as you can see, the smoke is much easier to see, and you can also very easily see that the smoke is kind of disappearing into the shop vac. And this is just to test to see that I actually have the flow around the bit, the flow I need also to get rid of all the very fine dust I know that the bit is producing always. You also can see is that the small chips it produces also disappears into the shop vac. So it seems that some setup like this could be a solution, so I will try follow up on this and see where it brings me. The burn test is an okay test to figure out what is the flow around the bit, but I also need to test some other bits and see how they produce chips and if the chips actually are vacuumed up, or how you say it. You can see this one here, this bit is also producing some small chips, and it's not all that is collected up to the vac. In the end, when I have finalized the pocket, I actually think it was okay with the collection of dust. So I moved on to the next test, and here I use a comp bit, a compression bit, and I just wanted to see again how many chips it produced. Maybe I should have made a more deep cut here, so I will produce bigger chips. Maybe I could also run a little faster, but I know this will probably not be my final test. And as you also can see here at the final result, not many small chips are around it. So I move on to try to create my own vac nozzle. And of course, again, I used my Fusion to do this and my old Chinese 3D printer. I needed to make 4 parts and glue them together to get the final result. So after a while, the printer finalized the printing, and I glued the 4 parts together. And I must admit, I am not too proud of that. Actually, I don't like it. So I am going to look for some other way to do it, and then I go to my shelf in my garage to see what I can get or find. And I actually found something interesting here. This is the vacuum, the vac connection on a normal router, handheld router. And I do have a couple of them from some old routers I have used for something else. So maybe this could be a solution. Okay, let's see what we got. We have this connection here from the handheld router. of course somehow need to go on a pipe, so I can put that to the shop vac somehow. But in the first place, I actually found out that the router connector did fit directly into this pipe here. So then I will try to put it like this. And in the first place, I will probably just have it to raise and lower together with the spindle itself. And to do that, I need, of course, to mount it, and I made this little bracket here so I can mount it and do some test again. So yes, I think this is the way going forward for now. After mounting it, it was time to put in a bit and see how everything was fitting together. And it was very easy just to pop it in the pipe. And as you can see also from the pipe here has a rubber gasket, so it's very easy to lower or raise the nozzle, or what you call it here. You can also see it here from the side how it looks. Very easy to lower, and again very easy to raise again depending on what you need. So I think next step here will be to try to mount something in the other end of the pipe so I can connect my shop vac and I can start doing my initial testing of this system here. The hose had to be mounted over a small beam I had just below my ceiling, so it was flexible for the router when it moved from side to side, forth and back. So it was pretty easy, and now it was time to mount a piece of test material so I could do my first test and see if it actually works. But before I make the first cut, I just lower the spindle so I could start the vacuum, the vac, and then try to feel the suction, how much suction it actually gave. And it didn't feel much, but it also felt like it was sufficient. So then it was time to do the first cut and then figure out if it actually worked for anything or it was not the way to go. So you can see here that in the beginning the vac is not running and it produces a lot of chips, and then I start the vac and the chips start to just be sucked out. Now you see the vac started. So it has a okay suction here and it seems actually to work fine. I'm not saying I'm a little surprised, but it's better than I actually expected. So no doubt I will try do more testing of pockets and try go fast, slow, try different bits and see how that goes. Looking around the test piece, you can see the chips it has produced, and all the chips we see here is not from this cut only, it's also from some of the other tests I have done. So I think all in all that this technique could be the way going forward, and I just want to remount it so I will have it not following the spindle, but I rather want to have it floating just over the test piece. So in order to do that, I think it is a good idea to cut the upper part. So here you can see it's cut, making a little more space. The space is needed because now when the nozzle, the suction nozzle, is floating over the test piece, I of course need to figure out how much space there are between the nozzle and spindle so the spindle can move freely and it does not interrupt or buzz into the nozzle at any point. So I'm not going to carve deep anyway. Instead, I think I will look into the mounting bracket here. I try to make it simple so I can raise and lower the whole pipe, but I also need some more restriction on the pipe so it will not move like you see here. I need to figure something out. That will be later. Maybe I should just run some tests first. So I have to mount a bit, and as you can see, it's very easy to swing it around. So the nozzle, as I call it, can be swung to the side, so it's easy to come to the bit and mount the bit. And after the bit is mounted, I just need to ensure that there are enough space below it, the nozzle or the suction. It just needs to be right over the test piece, so that will be fine. And also one of the benefits here to raise and lower the nozzle itself really easy is that when you are going to set the height, you can just raise it so you have the space for the piece you need on the top of the test piece, and then after that you can just lower it down so it will have the height just over the piece of wood you are carving. So first test where I have it close to the test piece, and I'm a little optimistic here because I saw how effective it actually was when it was hovering about 15 millimeters over the test piece, and it did work. So my expectation here is now that it will take the most of the chips and of course also the most of the dust it produces. And taking a view from top down, it's also easy to see that the suction is working very well. Not much is going to be thrown out below the nozzle, the dust nozzle here. Also you can see that I have about 40 millimeters, so let's say I can make a pocket at 40 millimeters, so that will actually be a good pocket. I don't think I will do that many times. So after running different tests, I also try to run a surface test just to produce some tips and see what's happening and how many chips was spread out around the piece, the test piece. And this is what I got. I don't think that's much, but I'm also wondering if it could be a benefit to put on a kind of brush. So I found something in my garage or workshop and figured that that could be okay for a test. It's a little stiff, and here's the result after mounting. But I think let's give it a try and see how it works. It is moving a lot, so you can see that the nozzle and the spindle are moving. They are not kind of following 100% each other. So I will update the pipe here. So as you can see, the pipe has now been changed, the gray pipe, and now I'm trying to run another test on a bigger piece of wood. And as you also can see, it produces a lot of chips floating around, so I don't think this is the solution to have the brush mounted, so I will try to figure out if there is another way to get rid of the brush and construct something else. A little wrap up of how it ended up with the suction system in general. I mount the vac directly on a hose going down to the pipe, and the pipe is 40 millimeter at this point here and going down to the same nozzle as I had before. And you can see here, if you look closer, that there is a small plate in the bottom and the plate has a small hole, and in that hole I just figured maybe it was better, but actually I don't think that was a solution. So I had to change, and I created something new. I was preparing for all my work in 3D Fusion and the 3D printer, all that stuff, and just tell you that I figured this out, and in the same time I upgraded to a 50mm pipe instead of 40, and this foot here, as you can maybe call it, it actually worked after the same principles as the nozzle I had before. I had a little accident, as you can see here, but it's plastic, so it doesn't matter. What I want to show here is that it has some sharp edges inside, and I want to change that. And to do that, I just go into my Fusion, change the radius in the 3D model, and then I 3D print it again, this time with my Warren printer. And the lower one here is the one with a better flow. It's easy to see. So in the same time when I was printing, I also printed a nozzle here, or an adapter from 100 to 50. I'll show you later what it's used for. First test with the new dust collection will be a carving. I will try carve some letters and see how much it actually works. And here in the beginning, the suction is not running, it's just carving, and you can see it's spreading some chips, not much, because carving do not normally produce a lot of chips. But then I start the vacuum, and now I can actually see that the chips is going to be sucked up in the nozzle, or what you call it here. It works relatively okay. I think it should be closer to the top of the piece here where you are doing the carving, but for now I have to have it in this height because I'm using clamps to hold it down, and of course I don't want to go into the clamps. Next step is to run the profile around the text, and when you're doing this you normally get a little more chips. So it will actually show if this is a good principle and it works. And for small bits like this, it seems to work okay. There are still some chips not going to be sucked up. You can also see that it produces a lot of chips here, and right now I probably need to figure out to get closer to the surface. And the closer I get, the better I will evacuate all the chips. So I probably just need to figure out how to get rid of the clamps and then put it directly on the board. I tried with double-sided tape, and that works also very well. But for this test here, I also wanted to see if it was producing chips, and a lot of chips, and how many chips when I had a little distance between the surface and the suction. Looking at the chips that it has produced from this small cut here, I can see there's a lot. So either there is not enough suction, and I think that's the reason here. I will show you in a minute why. The reason is that I went up to a 50mm pipe, but I also changed the vac out. So instead of having the vac, I actually bought a small dust extraction, and you can see it actually is 100mm in the connection for the inlet suction. The dust collector itself is a small dust collector. It's only 750 watts, so not a big one. Changing the shop vac with this dust collector here, I knew from the beginning that I would be challenged because the CFM is just too low. I was thinking 750 watt, well, I could probably spare some kilowatt hours, but I can see it's not the way to go. So I probably need to buy a new sub bag. It should be one with a 2-inch hose, and then I think I'll get enough suction to fulfill what I need for my dust collection. So I need to rethink a little here, but I don't think that will be today. The main purpose for the dust collection I did for now is to get rid of all the small and fine dust, and I'm quite sure and pretty sure I'm doing that. I will continue doing some tests with MDF, and then I will for sure know if my PM25 will be high or low. For now, I don't think I will think more about that. I would rather look into my bed since it's not straight. I want to have a straight bed and a spoil board. So thank you for watching and have a nice day.